So let us look at this question. In this question, you are asked to differentiate tan root x using first principles. So that means the given function is nothing but tan of root x. So you need to differentiate this. So f dash of x is equal to, so what is the first principle of differentiation? Limit h tends to 0, f of x plus h minus f of x by h. Now, what is f of x plus h? F of x is tan root x. So limit h tends to 0, tan of root of x plus h minus tan of root x by h. Tan of root of x plus h minus tan of root x by h. So now you need to find the value of this differentiation. So how can we find this? What I do is I'll multiply and divide this with 1 plus tan of root x plus h into tan root x in the numerator and denominator. So 1 plus tan of root of x plus h times tan of root x. So now once I multiply and divide with this expression, so now carefully look at this expression. So this looks like tan of something minus tan of something by 1 plus tan of something into tan of something. This is tan A minus tan B by 1 plus tan A into tan B. Tan A minus tan B by 1 plus tan A into tan B. This is the formula for tan of A minus B. So that is limit h tends to 0. This becomes tan of root of x plus h minus root x. This whole expression. So divided by h into, so this is a non-problematic part. This does not lead to indeterminacy. So you can directly do the substitution. As h tends to 0, this is 1 plus tan square of root x. So this lies in the limit. So this can be separated because there is no indeterminacy in this expression. So 1 plus tan square root x is nothing but secant square root x. So this got separated. So that is secant square root x times limit h tends to 0, tan of root of x plus h minus root x by h. So let us see how you can find this limit. So now as h tends to 0, you can see that inside tan you have root x minus root x. This expression goes to 0. As h tends to 0, this expression goes to 0. So if this expression goes to 0, if you divide exactly with this expression, tan something by something as something goes to 0 goes to 1. So that is equal to secant square root x times limit h tends to 0, tan of root of x plus h minus root x by root of x plus h minus root x times h into root of x plus h minus root x. I have multiplied and divided with this. So as root of x plus h minus root x goes to 0, tan something by something goes to 1. So this expression goes to 1. Now what is remaining is this expression, root of x plus h minus root x by h. This can be very easily solved by rationalization process. So I'll multiply it with root of x plus h plus root x and root of x plus h plus root x. So what happens in the numerator? X plus h minus x. This a minus b into a plus b is a square minus b square. That is x plus h minus x. So you get h as the answer. So this combined expression and h gets cancelled. So now the indeterminacy has gone completely. So now you can do h is equal to 0 in the remaining expression. This will be root x. This will be root x. So 1 by 2 root x. So the answer is secant square root x into the value of this limit is 1 by 2 root x. So this is the differentiation of tan of root x. So this is how you can find the differentiation of this complicated function using the first principles. So in this question you are asked to differentiate x square cos x using first principles. So f dash of x is equal to limit h tends to 0 f of x plus h. F of x is x square cos x. So what is f of x plus h? In the place of x you have to put x plus h. It is cos of x plus h into x plus h whole square minus f of x is x square cos x divided by h. So limit h tends to 0 f of x plus h minus f of x by h. So if we can find this limit, that is nothing but the differentiation of this. So let us see how we can find this limit. So that is equal to limit h tends to 0. So whenever you have product of two functions, use a standard way to find the limits here. So what we do is here, if you observe carefully, here in both the functions you have x plus h, and here in both the functions you have x. So the process is something like this: x plus h whole square times cos of x plus h. So you subtract and add a term here. So minus of x plus h whole square times cos x. You subtract and add an intermediate term, that is one function replaced by x plus h, the other function as it is. So I'll subtract this and add this also, x plus h whole square times cos x minus x square cos x is as it is and divided by h. So you can as well choose x square cos x plus h, that is your choice. But what we do is usually we use to subtract and add an intermediate term, that is half of the function converted to x plus h, the other half as it is. So see what happens when we do this. That is equal to limit h tends to 0 x plus h whole square. In the first two terms x plus h whole square is common times cos of x plus h minus cos x by h. I am separating the first two terms and the next two terms, plus limit h tends to 0. In the second two terms cos x is common, cos x times x plus h whole square minus x square by h. So here the indeterminacy is in this term. This is becoming 0 by 0. This is not indeterminate. This can go out. Here cos x is a constant. It can come out because the limit variable is h. So that is equal to x plus h whole square. H goes to 0. So this directly becomes x square. And limit h tends to 0 cos x plus h minus cos x by h. This looks like the differentiation of cos x, right? So this looks like the differentiation of cos x. So similarly, as we have done the differentiation of sin x, you can also do the differentiation of cos x. So limit h tends to 0. So cos x plus h minus cos x by h minus cos x by h plus cos x times limit h tends to 0 x plus h whole square minus x square by h. So now these two are very straightforward limits. This we have already done. So how did we differentiate sin x? So you have cos x plus h minus cos x. So cos x plus h can be expanded. That is equal to x square times limit h tends to 0. What is the expansion of cos x plus h? Cos x cos h minus sin x sin h minus cos x by h. And here, what is the expansion of x plus h whole square? X square plus 2xh plus h square. X square and x square gets cancelled. Plus cos x times limit h tends to 0. So if you expand this, x square and x square gets cancelled. So h square plus 2xh by h. So in this, these two terms can be combined. That is equal to x square times limit h tends to 0 cos x times cos h minus 1 by h minus sin x times sin h by h. I have separated this into two terms. Plus cos x times 1h gets cancelled. And after this, if you put h is equal to 0, this becomes 0. This becomes 2x. And here, as h tends to 0, sin h by h goes to 1. And as we have already seen in the differentiation of sin x, cos h by h goes to 0. So this term goes to 0, this term goes to 1. So minus sin x into 1 is minus sin x. That is x square times minus sin x plus cos x times 2x. So this will be the differentiation of x square cos x. X square cos x differentiation is this from the first principles.